Moving on to example 4, talking about scalar multiplication. Scalar multiplication is pretty much any time that you have a number in front of your matrix. So when you have a number in front of your matrix, so as we can see here, there's a number. Here's a number in front of the matrix. Here's another number in front of this matrix. Anytime you see that scalar multiplication, you're going to pretty much distribute that to every single element. So you distribute your scalar. This 3/2 would be that scalar. This 3 would be this scalar for this matrix. To all the items, or all the elements inside your matrix. So for example, with example 4, we can go ahead and distribute in this scalar multiplication. So 2 times -1, that would give us -2. 2 times -3, 2 times +3 I should say, gives us 6. 2 times 0 is 0. 2 times 2 gives us 4. Now for this negative, really, there's a -1 there. So we could even distribute this -1 to all of the items and change this to a plus. Because if you were to take like a plus, if I were to write here a plus, a negative, it's kind of like having 5 plus -3. That's the same thing as saying 5 minus 3. So I can go ahead and then insert this plus sign and then really just distribute this negative to all of the items. So when we do that, we have plus -1 times -3 gives us +3. -1 times 2 gives us -2. -1 times +1 gives us -1. -1 times +4 gives us -4. And the reason why we would maybe distribute that negative is because then we're really just adding these elements together. And usually that's a little bit easier for people to do. Before we can go ahead and combine these, right now we have to go ahead and jot down the order. We see that there are 2 rows, 2 columns. So this is a 2 by 2 matrix. This second guy, 2 rows by 2 columns. So in fact, that is also the exact same order, so we can go ahead and combine these. If you're really good and you can just like look at the items and notice that they have the same dimensions, then you're okay, and you can just go ahead and add these 2 together. So -2 plus 3 comes out to be +1. 6 plus -2 comes out to be 4. 0 plus -1 gives us -1. 4 plus -4 just comes out to be 0. So that would be our most simplified version for this matrix. For example 5, again, we're just distributing in this 3/2. So we would end up then with 12 times 3 is 36, divided by 2 gives us 18. 3/2 times -4 gives us -12 over 2, which is -6. 3/2 times 6 gives us, looks like 18 over 2, which is 9. 3/2 times 8 gives us 24 over 2, which simplifies down to be 12. 3/2 times -2 gives us -3. And then 3/2 times 0 is just 0. Plus, distributing in this 3. Looks like the top left is going to be 6, 3, negative 12, 3, 9, negative 6. Now checking to see if we have the exact same order. This guy is a 3 by 2. This one is also a 3 by 2. 3 rows, 2 columns. So we can go ahead and combine these. We can add these together. Adding the corresponding elements, 18 plus 6 gives us 24. Negative 6 plus 3 is negative 3. 9 plus negative 12 gives us negative 3. 12 plus 3 gives us 15. Negative 3 plus 9 gives us 6. 0 plus negative 6 gives us negative 6. So that would be our final simplified version for this matrix. So again, when we're talking about matrices and kind of the various operations, it's pretty much probably what you would expect, you know, when you're just kind of looking at the numbers. If you're adding two matrices together, you're literally just adding the numbers together. If you're trying to multiply something by a scalar, you literally just distribute that item in. Now when we're talking about equal matrices, these are the case where you're actually trying to solve for a variable. And what we're going to do first is go ahead and distribute in our scalar here. So we end up then with 4x. 2 times 0 is just 0. 2 times 3 is 6. 2 times negative 3y gives us negative 6y. That's equal to negative 12, 0, y, and negative 6y. Now, in order to actually go ahead and solve for the variable, just like when we were adding our like elements, so for example, 18 plus 6, notice we combined this top left element with this top left element. The same thing actually works for when we're trying to solve for variables. So in other words, this top left element should be equal to this top left element. So as a result, we can then set that 4x is equal to negative 12 and very easily solve for x there. Looks like it comes out to be negative 3. Now for our y, we can see from our bottom left, with our bottom left, that y just came out to be 6. If we looked at this one, these bottom right ones, you would just have negative 6y is equal to negative 6y, and you can't really solve anything from that. I mean, even if you tried dividing negative 6 on both sides, you would just end up with y equaling y. I mean, yeah, that's a true statement, like that's legitimate. But you're not really identifying what y is by doing that. So right here, when we looked at this bottom left one, and this bottom left one, we were able to say, yep, y is 6. So then for our x and y, it comes out to be negative 3, comma 6. So that's how we actually handle our equal matrices. We're going to try to solve for a variable by each element corresponding to the appropriate element. Now when we're looking at multiplication of matrices, so up until this point we've talked about how to add and subtract two matrices together. You know that they have to have the exact same order for that to happen, and then you just start combining your like elements. For scalar multiplication, you just distribute those items first, and then you can combine them. Equal matrices, just trying to pretty much solve for a variable here, that the corresponding elements must be equal. If this top left one is in fact in the top left, and it's equal to this other matrix, which has a top left element, then these two corresponding elements must be equal to one another. And that's how you can, again, solve for the variables. Now we're moving on to multiplication of matrices. Now, multiplication of matrices actually differs from scalar multiplication. Scalar multiplication is when you simply have like a number in front of your matrix, a single number. Matrix multiplication, on the other hand, is where you have some matrix and you are multiplying it by some other matrix. And in past years, it is crazy common. So, for example, if I have, let's say, this matrix 1, 2, 5, 7, and that it is being multiplied by, we'll go with 3, 6, -1, -2. So again, just totally made this up. You do not have to jot this down. You can if you'd like. But it is crazy common. Probably one of the most common things I see in math, at least from the first approach, the first time my students see it, is, well, looks like we combined and added our like elements. Even when we try to solve with equal matrices, corresponding elements were equal to one another. When you're trying to multiply, and as a result, you might be thinking to yourself, well, I'm just going to go ahead and multiply this 1 times 3 and get 3. This 2 times 6 and get 12. This 5 times -1, -5, 7 times -2. It is crazy common that people at first think that's how you multiply matrices, because it worked in all the previous cases. However, how we actually multiply matrices is we're going to start out by taking the first row from our first matrix and multiply it by our first column in our second matrix. Then once our first row is done with our first column, we take our first row still and multiply it by our second column. And so that's exactly why when we're actually multiplying these two matrices, we have A times 1. So just multiplying these two, this first row and first column. A times 1 would give us A1, no, not the steak sauce, plus B times 2. That entire part, that multiplication part of the first row and first column, just goes in the top left. That would be that element. Then you have to move on to your next column. So you would pretty much just repeat the same process. A times 3, so we get A3, plus B times 4. So it's kind of this constant multiplying and adding of things. Yes, you will always see that adding between them. Alright? It's always going to be an addition between those elements. Now that you've basically used up this first row as much as possible, like there are no other columns in the second matrix, we are forced then to move on to the next row. Then you pretty much just repeat the exact same process. So C times 1, there he is, plus our second element times our second element, D times 2. Then we still use our second row, move on to our next column. So C times 3 plus D times 4. Now, if you're thinking to yourself, holy cow, I'm crazy lost. I don't understand what's going on here. What's the deal with the multiplying of matrices? Do not worry. We're going to see several cases of how to actually multiply matrices. Trust me, by the end of it, you should be pretty good on how to actually multiply matrices. In fact, in the past, pretty much all my guys have been. So right now, it might look pretty intimidating just because we have all these like A's, B's, 2, 4. But in the end, it actually starts making more sense when you start playing with the numbers a little bit more. Okay, so don't freak out for right now. We'll do a lot of examples so that you guys are pretty good and ironclad with this. Now, for the record, again, not feeling too hot. Not sure who it was, but I will find you. Now, I do have some strong leads pointing to Miss Moravik and her chemical warfare, or biological warfare, whatever. Thanks again, guys. I hope you guys enjoyed it. Hope you learned something today. And tomorrow when I come back, we'll be kind of just answering any questions you might have. So if you have those, please write them down, or make sure you're ready to be able to ask me for tomorrow. Again, though, guys, that's our 3-5 set of notes. Thanks again. Catch you tomorrow.